Alright, I think we're back online. Sorry about that, guys. I think, like, yeah, like something went off. Like, basically, my internet is not the best. Unfortunately, I'm still using, like, cable, because I still live with my parents, and, like, my dad, like, refuses to change it to, like, fiber optic or anything like that. So, we're back. Like, if that happens again, like, because, like, it took me a little bit longer because for some reason my OBS was not connecting to my, my stream key. So I actually had to like adjust things. But thank you guys for sticking around if you stuck around. I really appreciate it. I always hate it when that happens, when my internet cuts off and I'm like in the middle of stream. I'm like, oh dang, I hate it when that happens. Especially like with bad content. Like I wanted to keep it going, keep the ball rolling. And I think we still had like 6 minutes left on break time. So I think we'll just take those 6 minutes and then we will get back into it. But let's see. Rain time. I'm so glad it just reloaded chat back up. So that way I didn't miss what you guys typed. Yeah, my internet's not the best, unfortunately. But I tried with what I got, and you know, that's basically what it is. That's how it is sometimes. I just hope one day that I can get fiber optic, but you know, it's not up to me. It's not my decision. Like I'm actually wondering what you guys are working on, because I know some of you guys are working on research right now, or like doing some like awesome math stuff. But if anyone in the chat would like also to reply back if they haven't given their reply yet. What are you guys up to? The thing of it is that like we're still on vectors. We haven't gotten to tensors yet. Actually, I also like my new book is coming in today. Oh, thank you for the follow. Time for Wonder. I love that name. And if you're in the chat, like you know, welcome, as well as what's the best part of your day so far? Time for Wonder. I love that name because it has time in it, and also I'm into physics as well, so you know, time is the fourth dimension. But welcome. Best thing of the day, oh, failing the math exam today. Oh, I'm sorry to read that. Like, you know, like it's not the end of the world. I mean, like it's January right now, so well, it's about to be February, but you still have time to make it up. You know, like what type of math exam was it? And are you in university, high school, like, or grad school? Like, it's fine. Should learn earlier. Yeah. Studying, you basically have to manage your studying. Like, I think like if you spread your studying out like within a couple weeks, like if you just study like probably like an hour or 2 hours a day, I think for like school, like I think that's enough. Because like there's like I don't really believe in the rule where it's like basic math analysis. Oh, okay. Well, when I think about it, analysis, like even though it's considered basic by math majors, I feel like it's not really basic to the general public. I mean, I'm trying to learn real analysis myself, and I'm still struggling on the first part of the material. So, you know, like I always feel like analysis is sort of like undergrad upper level math, because that's when you actually learn proofs. You're in university? Okay, I'm guessing you're majoring in mathematics because you're doing analysis, or is it like a different, or is it like just something that goes along with a minor or major, another major you're doing? Let's see. Studying informer. Oh, I never. Oh, okay. I never heard of that. Oh no, analysis is probably the hardest course in undergrad, just because you have to learn proofwriting and finding estimates. Well, I didn't know about that last part, finding estimates, but that, yeah, because you're dealing with the real numbers, so it doesn't surprise me that you're doing that, because I think, like, in basic calculus, I never learned, I think it was called Newton's method. I never learned that. Like, I think we just learned the basic stuff, like derivatives. Like, we didn't even learn, the epsilon delta definition of a limit. And I kind of wish I did learn it, because that would have been better for me when I was when I'm like learning real analysis. I said taking, but I'm not taking an actual course on it. I mean, I'm taking Penn Center's course on real analysis, but like that was much more manageable for me than just like going to university again. I mean, I would love to, but you know, it costs like a lot of money to go back to university. Okay, I think it's time we should go back into our next study session. So I will be right back real quick. So just give me a minute, guys. Okay guys, I'm back. Sorry to keep you guys waiting. And before I end up jabbering more, I probably should start the study session now. Okay, but you guys can still chat amongst yourselves, and I will get back to you when I'm able to get back to you. But don't worry, don't feel like you're bothering me when you're talking in chat. I will just read it and then I will reply back. Let's see. For me, integration was my hardest trouble. Oh yeah, like I still have to restudy integration myself. So, obviously I know like the basic integration, like, you know, the power, like the reverse power rule. But when it goes to, I think trig substitution and, like I think partial fractions, yeah, partial like fractions, those I have to relearn. Like I have to retrain myself on those. Yeah, the key to understanding analysis and proofs is to do examples, a lot of examples. Right. I agree. And it's kind of funny because like in like proofs courses, like I think I don't know if this is true or not, but I heard that a lot of students would raise their hands and ask the professor would give them a lot of examples, but then the professor would be like, what example do you need? I just gave it to you. Because I think it's just mainly because it's proof based and you're like kind of thinking like the students like already know how to prove things, but then you realize that they haven't developed the rigor yet. I mean, I feel like this is right, but at the same time, there's this -2 here. Unless there's something I'm missing. I have to look it up. What is the law of cosine? Oh, I was right. Okay, so that is the way it's structured. Okay, I'm surprised I actually remembered that. But I'm wondering what am I missing? Because I feel like the proof's almost done. It's just that I just wonder where this -2 goes. Because I know you divide the 2 into the other side. I'll try my best. Yeah, try your best. And in fact, like, if you guys, like, want to join our Discord server, please join our Discord server, because I would love to have a study session with you guys. Because, like, if you guys are already in university and learning all this cool stuff, like, I want to be able to be, like, I guess your, like, student lecturee, because I think the best way to learn something is if you teach it to someone else. And, like, since I love learning things, like, I'd rather be, like, that student that sits in while you're just giving, like, I guess, sort of your study/lecture on the thing that you know. Sorry if you guys hear me chewing. I always take a cough drop whenever I'm streaming, because I know I talk a lot during, like, these streams. I feel like this is right, but at the same time, I'm like, what am I missing here? I'm definitely missing something. Wait, I have to check out the law again of cosine. Actually, I should have just reopened. Yeah, it's -2, right? Yeah, it's -2. Huh. Oops. I also have like a book on mathematical analysis. I think that's the same book that Tensors course is one of the 3 books. I think one of the 2 books, because I do have Abbott, but I didn't have the other one, so I had to like basically ask Tensors to send me a link to the second book. I always remember. I just remember it's Pythagorean theorem, and then you just need to subtract. Yeah, that's how I remember it actually, because like remembering it that way is so much easier for me. Because I feel like that's how you prove it, but there's still that -2. Why is that like, where does the negative go? I mean, I don't think it just vanishes. Yeah, because it would still be here. Maybe I should take my time away from it for now. Because I feel like that's how you prove it. The thing of it is that I'm not sure if that's the right method. Unless, like, the thing of it is, I don't know if that's the method they're expecting you from this book, actually. Like integration, differentiation, and then also proofs, and, oh, okay. Now for this. Now for the cross product. This one is going to be even harder for me because I have seen the proof for the dot product, and I think it goes that way, but for the cross product, I kind of feel like I don't know much about this one. I know you're supposed to use the law of sine. Actually, do I even have the law of sine right? Let's see. Law of sine. Law of sines. Okay. So I was, like, my guess was correct, okay. Oh, it could be either one? I didn't know that. So I was right either way, even if I wrote it on the bottom. So it doesn't matter which way it is. Oh, okay. I always thought it had to be a certain way. Because I remember some books would show it like the other way and some books would show it the other way. Or the way I would do it. Okay. So I guess I was partially wrong, but not partially right. Oh, partially right, but not... And also partially wrong. Or something like that. I don't know. I'm making up words. Okay. So A cross B. Unless I'm making it more difficult on myself. Because it's one of these signs, so I'm guessing maybe the sign of C. I'll probably come back to this one. Because usually when it comes to like the problems that say like prove something mathematically, I always psych myself out for those. Especially when it appears in a physics book, because I'm like, oh my gosh, I have to actually know this. Oh, no, I forgot. I moved it up here. So I'll just skip that for now. Oops. Probably let my brain, like, just do, like, the simple ones first and then just go back to the hard ones. Well, I say simple, but at the same time, it's like, I would probably say the problems that doesn't take too much time for my brain to actually think outside the box. Oh, hey, Jeff Seagrove. So the problem is I have to show that the dot product of vector A and B is equal to the magnitude of A and vector A, and the magnitude of vector B is the cosine of theta. And I also have to show that the cross product of A and B is the magnitude of A and B sine of theta. That's what I was trying to show. Because I know you can prove the dot product through using the law of cosine, but then again, I don't know if that's what the book actually wants you to do. Because I'm probably making it much more difficult than it needs to be. But how are you doing, Jeff Seagroves? What was the best part of your day so far? Using the vectors of the previous two problems, find the triple product. Oh, okay. Of previous... Oops. Can't spell. I can't spell. Doing good. Got a lot of boring stuff out of the way. Nice. Now I'm ready to annoy mass streamers. Oh, okay. Actually, Jeff Seagroves, I don't know if I asked this like before the last time you came onto my streams. Like, are you working? Are you a student? Or you're just like really into math? Oh, you're retired. Oh, okay, okay. So you just do math as a hobby. That's good. Like basically like I think like people like I think mathematicians when they retire they basically just do things that are not involved with math unless they get really, really bored. Previous two problems. Find. I used to be a compute programmer. Oh, okay. I see. I don't know how programmers do it. Like, just, like, be able to, like, create things. I think that's really cool, but at the same time, I'm like, wow, like, coding is, like, very intimidating to me. Like, even whenever I pick up a coding language, I would probably be motivated by the first couple of days. But then, like, when I learn more of it, I just kind of get bored with it. I mean, it's cool to, like, type it out and, like, basically have, the application read the language and produce what you've programmed into it. But it's like, for me, it's just like the motivation just kind of depleted. Although I do like Madam though. Madam is pretty fun. I just haven't kept up with it. I probably should get back into it. Compare your answer to B. Okay, triple product problem. I don't think that should be too difficult. Okay, previous two problems. Luckily they're in front of me, so I don't have to like move my notes around. So plus 2 is J, and B is J plus 4K. Okay, and then J vector J, that is, do that, plus 5K. Alright, now we have to do a triple product. Okay. So I think like the last problem we actually did the cross product of these two, didn't we? No, I don't think so. Did we? If I don't have to write it down, then I'm like, probably not. Okay, so I guess we'll just do it anyway. Cross product of A of B. Better to write the chart, because every time when I don't write the chart, I miss numbers. That 0, 1, 4. Okay. Now, plus J plus K. Okay, whoops. Okay, the first one is going to be, it's going to be Y, so it's going to be minus that, then dun 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 dun, and then it's going to be Z, so 0, C, and then dun dun dun, and then it's going to be X and Y, so X, Y, and then do that. I'll bring it down. I'll use my calculator again. That'll be 8 minus, well actually plus 1. That'll be 9. And then we have 0 minus, well, that's going to be 12. Right, yeah. Oh, that 4 looks like a 9. There we go. That looks nicer. Okay. Then, yeah, that's going to be 4. So, plus 4K hat. Okay. Now we do the dot product. So, the dot product of these two equals, so it's 2, 9 plus negative 1 it's negative 12 plus. So we're left with 18 plus positive 12 plus 20, which results in basically that equals 20. No. That equals 30, 50. All right, so now we got to do the reverse. Do the cross product of these. And then actually gonna switch. Oh. I didn't know I could do that with my pen. Can I change it back to writing mode? No, I can't. Okay, so I can change it to erase mode through here, but not through whiteboard. That's very interesting. Okay, so where was I? Oh yeah. So J is minus that, and then A, gotta make sure I'm writing A right, so 3, 2 plus K. Okay, perfect. Actually, time for wonder. It's actually interesting that you're getting into AI. Like, I'm wondering, like, how universities are actually making programs around that particular subject now. Okay, so now we gotta do the hard part. Putting these puzzle pieces together. What fun. Okay, so first off, we got Y and Z. So minus then we got Z and Y, X and Y. So then the first part should be, yeah, it should be Z. So this one right here, minus 2 minus, and then it should be X and Y. So then do that. Oh, wow, that's very messy too. And then minus -1 or 3. Okay, then we end up with 10. Positive and then minus again. -1 plus 15 plus 2 plus 4 plus 3. So 9 plus 17 plus 7. Okay, I want to make sure that I did those correctly. Okay. J is basically these two, right? Yeah, so that's correct. Yeah, okay, that's correct, okay. Okay, now these dot product of B. So that's gonna be 9, 0, 17 times 1, then with 0 plus 17 plus 28. Thusly, we are left with 5. You carry the 1. That makes it 49, 40, 45. Compare the answers. Okay. I mean logically it's going to be a different vector. Yeah, I think it's going to be a different vector because of the cross product. And then when you do the dot product with like either another vector, I think it's going to be different. I don't think they're commutative because I know the cross product is not commutative. I'll recheck it like at the end. Okay, let's pull this down here. All right, so 2.5. Oh, it looks like we're gonna have to use the same vectors again. Using the vectors of the previous that's from the last one. Let's see. Problems 1 and 2. Find the triple product. Oh, the triple vector product. J cross A B and compare your answers. Compare your answer to times, well, not times, like the cross product of B and yeah, I think these are going to be different answers given the fact that they're all cross products. But actually, I want to double check this for a second because this one is actually bothering me. Oops. I want to make sure I did everything right here. Okay, so those are lined right. What's your background in linear algebra? I have taken linear algebra before. I've taken a course on it. It's just that I haven't done it in a long time, actually. Like, I do know, like, you know, the cross product and the dot product. It's just that I'm trying to I'm trying to bring those muscles back. So, like, I don't remember things like linear transformations or eigenvalues or eigenvectors. So I gotta work on those. I'm just basically trying to, like, see what I'm missing. I think this one I probably did. I think this one is a bit off. Yeah, I think this one's off. Because I remember the first one is supposed to be y. So it's like y. And then you do this back here. So technically, we can make that -9. Then this one, that's correct because it's supposed to be z first. Then, yeah, this one's correct. And boom, boom, boom. Done, done. Yeah. Yeah, that's correct. Okay, so I was wrong on this part. But that didn't matter because we just basically just got rid of it. Okay. Okay, so I was probably being a little paranoid about that. But I think I did everything correct on that one. Alright, so I want to copy this. Smart draw, lasso. Because I don't want to rewrite this again. There we go. Okay. Cross product of these. This is gonna be fun. Did we do A and B already? Yeah, we did. So we already know A and B is gonna be I actually want to relearn linear algebra so I can get into quantum mechanics, because I know quantum mechanics uses a lot of linear algebra along with partial differential equations, but we'll get there when we get there. And oh, so we didn't do J and B, but we did J and A, so we'll do J and A. Oops. So J and A, that is -9 plus 17 plus 7. Okay, so now we just need to do J and B, J cross B. Quantum mechanics is all linear algebra. Oh, okay. That's good to know. That's good to know. And functional analysis. That's good to know. That's good to know. That's good to know. Because I also want to get into differential geometry. Because I also am curious about general relativity as well. Okay, so J's first. So J goes on top, like this. I'm guessing everyone's busy doing their own thing, just relaxing, and just, well, not relaxing, but just basically focused on doing their own task. You guys are just being absolutely productive. Hopefully you guys are just like doing problems that basically keep you engaged. I have no task. Oh, playing AC3. Oh, okay. Well, I hope you're enjoying your game. Okay. So the first one is supposed to be Y and Z. So boom, 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 and then the next one is supposed to be Z and X. So that's a 0, right? Yeah, that's a 0. So boom, 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 and then boom, boom, boom. There we go. Last one is X and Y. Dot, 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 dot. Okay, -4, -5, I, 0, 8. I think that's a 0, right? Yeah, that's a 0. So it's just 0. Okay. And then we are left with -1, or -I should write. And then -8, then plus 2k. Eating lunch, does that count? Yeah, it counts because you're being productive with your body, giving it energy. So that works. It's better than thinking about work. Work is destroying my soul. Oh, tears. I'm sorry that work is destroying your soul. Hopefully, I'll give you more positive vibes. I'll give you positive vibes to basically cleanse your soul from the strenuousness of your job. Bring this down here, and then we gotta do. Oops. So the first thing we have to do is J cross AB. What fun! I forgot this was the cross product, so now we gotta do the chart all over again. Okay, so J is first, so 2 minus 1, 5, and then 9 minus 12, 4. Okay, the first one is Y and Z. So, wow, like, my handwriting just doesn't want to cooperate. I'm trying to present you guys like some good math, and yet my hand is making everything look messy. But that is partially my fault. 5 times -12. It's I. And then next one is Z and Y. Oh, Z and X. Z and X. So. General theory of smooth manifolds requires a bit more topology. Yeah, that's why I'm trying to study a little bit of real analysis as well, because I know real analysis comes in handy when it comes to topology. Of course, I still have to get through like the first regiment, like, you know, the axiom of completeness, as well as basically solidifying my knowledge of the triangle inequality. As well as, like, you know, the other basic stuff, like, you know, sets and how to set up a proof and all that stuff. So I am far from learning topology at this point. The last one is X and Y. So minus. Okay, before I go into it, I want to make sure that every number is lined up. So, boom, boom, dun dun, dun dun, dun dun, right, boom, boom, dun dun. Okay. -4 plus 60 plus 45 minus 8 plus -24 plus 9. Okay, so minus that would be 56. 56i plus, then make that, so it's 37j. And then that'll be negative. That'll be 14, so 5, so 15, yeah. Yeah, so this would be like -15. Okay, so that's one of the answers. Then the next one we have to do J and B. Just write it down ahead of time. J and B. Or is it J and A? Yeah, it's J and A. That right there. Lucky I double checked. Then cross B. Hello, Bamboo. How are you doing? What's the best part of your day so far? Extra tired? Aw, tears. Well, hopefully you're home and just able to relax. I hope so. It's easier to start with the embedded surface in R3. Like, what do you mean by embedded surface? Like, are you talking about just a flat Euclidean space? Or something else? I still have to take Calc 3, actually. I haven't taken Calc 3 yet. I only know some parts of Calc 3 because, like, of this book, actually. I actually understood what... I actually learned what divergence and curl and the Laplacian is. I think with triple integrals, I learned that online because, like, I think, like, I was just curious about about those, and I was like, how do I solve, like, double or triple integrals? And I just looked it up. So J cross A, that's -9, 17, 7. Like the sphere in 4-3. Or torus. Oh, okay. Let's see, the best part was no part. Oh, I'm sorry to hear that. I gave 3 lectures today and... Oops. I gave 3 lectures today and it sucked. It went well, but the students were annoyed except teaching Stellar Chem was surprisingly good. Oh, okay. Drove back home, but it took me 1 hour and a half instead of 45 minutes because traffic. Oh, I'm sorry to hear that. But I need to do math right now. Probability and stats. Oh, okay. Well, I'm sorry that your day was so strenuous. Oh, Bamboo, thank you for the follow. I thought you already followed already, but I guess I guess you just dropped the follow right now. So thank you very much. Thank you very much for the follow. Always appreciate it. And I like, you know, I'll give you more positive vibes since you went through a strenuous day. You know, more positive vibes to you, as much as I can spare. I don't know if it helps, but you know, hopefully it does. You know, because like you put in a good day's work and you know, like it just weighed you down, and I'm sorry to hear that. I just realized I didn't. Oh, okay, okay. Yeah, because I remember seeing you last stream, and I thought you did during that stream, but then again, like, I guess I should have paid more attention. It's fine. It's okay. It's okay. Good, good, good. Where's B? There it is. Okay. Now the fun part, putting all of these together. What fun. I think just writing it is like very tedious, but at the same time it's like, gotta make sure it's right. My attention to detail will always kick my butt. Even though I still miss things, even though I try to do things correctly as possible. Okay, so it's supposed to be Z index, so... Uh-huh. And... like this. 4. Then J. Then plus... X and Y. Then minus... Okay. I need to do MC inference. Oh, I don't know what those are. Which is fine. I've never heard of those. But you said it involves probability and stats, so I'm guessing it's like something involved with like those subjects. I'm just gonna finish writing the last part. Right, yeah, because, so it's 36. I'll double check. 9 times 4. Sometimes when I think I know the arithmetic, it just goes in my face. And it's like, nope, you're wrong, you missed something. And I'm like, oops. Okay. My brain is starting to ring. Sorry, was it the break time buzzer that causes your brain to ring? Let's see. Minimum likelihood estimation is the fitting models data to determine stellar luminosity functions of exoplanets. Oh, that sounds cool. Actually, Bamboo, like, do you mind if I ask you what you did, what you do for a living? Because you said you gave a lecture, so are you a grad student or are you actually a full professor? Well, it's break time, so it's time for us just to relax a little bit. I did my PSC in physics and SSC in astrophysics. Oh, nice. Okay. So you're actually in the field that I really, really admire. Like, I'm very interested in cosmology, actually. But astrophysics is, like, basically, like, a part of that, so, you know. Like, I can ask you some, like, awesome questions. I mean, what are you researching right now? I recently started lecturing because I need the certificate. Oh, okay, okay, I see. To apply for a better PhD. Oh, okay, okay, okay. I see, I see. Well, I'm guessing you are going for your PhD. I mean, best of luck to you. And hopefully you're also keeping your health in check as well while you're doing that. I know it's going to be like a lot of hard work. Nobody wants me to research for free. Oh, that's Dang, if I was part of like an undergrad program and I was taking your courses, I probably would volunteer. I would probably volunteer. Because I'd be like, hey, I'm like, like I'm actually doing research. I'm actually helping somebody, My health is debatable. Aw. Well, like at least try to take care of yourself at least. Because I know I know PhD students, they go through this I guess unhealthy regimen, like I don't like to think of it as a rite of passage because that's not right to make your health go down the drain because you really love the knowledge of the subject that you're researching. And I know you're doing it for like to be able to get paid for it like in the future. Right now it's 2:24 a.m. Oh, for you? Oh, dang. Do you mind if I ask where you're from? I sleep like, dang. Oh, I'm sorry to read that. Oh, you're from India. Oh, okay. That's a very, like, intense schedule, though. Yeah, but at the same time, like, I just want you to, like, be able to take care of yourself, as well as get to the career path of being, like, a researcher and stuff. Hey, Vemvox fam, how you doing? I'm preparing for Jess and Gate 2. Oh, okay. Are those, like, exams? Like, for more certification? I don't think I've ever heard of those. Joint is entry screening test and graduate aptitude test. Oh, in engineering. Oh, okay, gotcha. What was the best part of your day so far, Vemvox fam? Doing fine. I learned a little linear algebra today. Nice. Congratulations. Clap to you. I don't have like a soundboard for claps, but like congratulations to you for learning a little bit of linear algebra today. That's good. A little bit of learning every day is always good. I don't really like people that do long study sessions. Like I love doing these study sessions with you guys because you guys still chat with me even though it's like a study session. But like I feel like math is sort of like a passive activity for me. Well, not passive. It's like an active activity that allows me to also feel like I'm having fun. And when I'm talking to you guys, it makes me feel as if like, oh, I'm just chilling with my friends, but I'm also solving like stuff, which I think is really the fun part. I study like 16 hours a day. Oh man, like I give you creds if like that's your daily like if you can make that your daily regimen and just like not feel fazed by it, but I can't do that. So I give you credit for like being able to study that long. I mean, you are doing research, so I know you're just basically like looking up stuff and probably refreshing your mind on stuff that you learned and you probably have to refresh it. So, like I give you like massive credit to be able to do that. I can't do that. I can't study for 16 hours a day. I think because of you guys, I'm actually being able to study better because of these streams, actually. Because it motivates me to actually like learn more. Because I think like once the stream is over, I sometimes think about what exactly I should learn next. Even though I probably might not be good at it. Right now I'm not doing research, just preparing for exams. Oh, okay. I'm glad I can ask you things. I mean, like the thing of it is that like what exams do you have? What courses are the exams for? If you don't mind me asking that. Because I'm really interested in like quantum field theory and general relativity, but I'm nowhere near like the level to take those yet. Because like I gotta review like basically like basic physics and stuff. Like I think with physics, like I did take an online course on physics, but like I didn't get a certificate or anything. I just learned it for my own benefit. But I barely remember anything about electromagnetism. And I know I have to get back to learning that. I do remember things like, the kinetic formulas and like, obviously the, like the Newton's laws, potential energy, kinetic energy, Like, I only know, like, I think, like, probably the first half of, like, Physics 1. But then when it came to, like, electromagnetism, I probably feel like I didn't develop enough methods to, like, have my mind solidify that in long-term memory. Because, like, it is an interesting... I am interested in electromagnetism. The thing of it is that I don't think I developed the right, I think, like, mental tricks to basically have my mind remember them. But then again, it could those could be better remembered through, like, experimentation. These are just exams for PhD admissions. So it's like a scorecard for any course under science. Ah, okay, I see. It will depend on my rank. Oh, okay, I see. Well, I mean, like, you know, like, do you know what you're gonna research for your PhD thesis? And if anyone's out, if anyone's gonna do a PhD, you know, credit to you, because you're actually dedicating your life to be like in a field where it, like, you know, scientists are, like, you know, trying to find, like, data on stuff that they don't know yet. So, you know, I know everything about quantum field theory. Oh, nice. That's very nice. I actually have a book called, I think the title is called Quantum Field Theory for, I think it's called Quantum Field Theory for Gifted Amateurs. And I looked at the first page of that book and I was like, oh, I am not at the level to read this yet. So, you know, like, I have to learn, like, more linear algebra and, I think, like, partial differential equations, as well as, I think, like, the calculus of variations. I'm nowhere near that to be able to learn that yet. If I have physics questions, I'll ask you. Cool. Yeah, like, I also want people that love physics to come in to this the stream as well. I read an introduction of quantum field theory by oh, okay. I'll probably write that down. Actually, I have my notebook with me, so I'll write that title down. I think someone in chat mentioned an author that I should read, that writes fiction based on physics and mathematics, but I forgot the name of the author. So if you're in the chat, like, I don't remember who it was, but if you're in the chat, remind me who that author was. Let's see, quantum field theory. Theory by Michael. Okay. I mean, it's a grad level course. I see. Yeah, because I remember I was talking about my I was talking a little bit about my novel. Like, well, I don't want to say it's my novel. It's a story I want to develop. And the characters use, like, math and physics laws to basically control everything around them. But, like, I'm trying to develop it in a way where it doesn't violate the conservation of energy. So, like, basically, like someone recommended a fiction author to me of who I should read, and, like, apparently this author is, like, good at making, I think, stories revolve around that particular subject. But I don't remember the name of the author that the person recommended, and I don't remember who in chat recommended that author to me. Yeah, it is going to be tough because, you know, like, fictions, because the thing of it is that, like, it's not like I'm trying to prove, like, it's obviously, I know it's fiction and it's not gonna, like, basically there's gonna be a lot of, like, scientific fallacies in it, but at the same time I don't want to make it so it's like the characters are super powerful and they're just basically just solving their problems willy-nilly. It's like I have an idea what the limit of the characters' powers will be, the thing of it is that I don't know how to create actual scenarios where they have to implement their knowledge of like mathematical constructs and you know, like physical know-how to basically overcome their opponents, because their opponents are like higher dimensional like space-time beings that are able to manipulate the laws of physics to a certain degree. So, like, thinking about the actual combat in the story is the thing that has prevented me from writing it, because I want it to sound like, you know, like, I guess, like, almost close to, like, well-researched as possible, you know? But I know I can't research every single thing. Because I said last stream that the characters' limitations is that their powers are basically derived from power series, and the only way they can implement their powers or implement the ability to manipulate things around them is due to the radius of convergence. So they have to make sure that they're able to tap into the radius convergence of the power series that they're implementing within the construct of whatever it is that they're trying to do. Of course, I haven't fully thought of, like, you know, how I'm gonna do that yet. Like, within, like, the storytelling perspective. But that was, like, the best thing I can think of, like, because I just recently developed it. The idea, I mean. Developed the idea. I know some powers, we can explore harmonic oscillations, resonance, and Fourier transforms to amplify and cancel vibrations. Okay, I'll keep that in mind. Actually, it can cancel destructive. I'll probably write that down actually. And I know break time's about almost over, so it'll probably be the last study session, and then we'll probably conclude. But I will write down what you typed up, Bamboo. Let's see. Actually, I can probably just put it in my notes. I can just copy and paste that in my notes in my other screen. I don't have to write it down in my notebook. Luckily, I have Notepad open, so I'll just copy this, put this in here, and copy this. Thank you for the suggestions. I really appreciate it. Because, like, there was, like, a part of me that actually wants to make my own anime one day. But then I was like, maybe I should just write a light novel. But I've been thinking about the idea for years, and I haven't gotten to writing it. Let's see. Alright, if we solve Navier-Stokes equations, we can create turbulence and Lamier flow to control gases and liquids around them. It will use real-time differential equations to predict and manipulate trajectories, optimize paths, and control fluid. Ooh, that sounds intriguing. Altering airflow for lift or redirecting water currents. Oh, okay. That sounds cool. Yeah, maybe I should share more of my story ideas with you guys, and maybe you could probably like put in like it's fallible or not. Like, because the thing of it is that the reason why I got into math and physics, obviously I did catch the string theory bug, but like I think further down the line I've seen more physicists criticize it. Like, but at the same time, I also like the idea of the quantum gravity and all these other theories that come up with ideas towards, like, you know, quantizing gravity or uniting gravity with quantum mechanics. So, you know, I think that pursuit is, like, really, really cool. Like, either way, whatever angle it goes. I mean, like, if they prove that the multiverse isn't real, then, yeah, like, I'll have to accept it. But at the same time, like, you know, I mean, in my heart, I believe it exists, but obviously there are some physicists and scientists that are experts that know more than me probably say it does not exist. And, you know, that's fine. I have to accept it either way. But I think the multiverse is fun. It's a fun idea. Writing a novel will take more time considering on your funds and budget for animation. Yeah, right. That's why I think like writing a light novel is probably better because it takes less time because you can just upload it online, make it an ebook. You also asked about my thesis. I'm not still sure about what to do, but if you have ideas, like, you're free to share. I mean, you're trying to find people to help research too, which is like really cool, actually. I mean, I don't think I'm like in the right like if I was actually studying what you're doing right now, I probably would volunteer to like help you in your research. Because that sounds fun. That sounds really fun. I want to test the nature of dark matter and dark energy with gravitational waves. Oh, that sounds really cool. GFT approaches to dark matter and dark energy. Oh, that sounds really intriguing. Exciting too. Not many people understand what I do. That's fine. I think like that's how it is. Like, especially with the general public. But I think I think the ideas you point out are like really, really cool. So I say, yeah, I would say go for it. Like quantum theory, quantum field theory with dark matter and dark energy. Like, not many people. I think I saw like a Star Talk episode where they were talking to a particle physicist, and apparently like they don't know anything about dark energy or dark matter, like within quantum field theory. And like I think there's a big mismatch within that field with like how much dark energy and dark matter there is in the universe. So yeah, I would say go for that. That sounds like a really good place to start. You know, like, I mean, it's gonna be very, very hard. Don't get me wrong, but at the same time, it's exciting. It sounds exciting, actually. We need to study whether dark energy arises from the vacuum or is a dynamical field. Oh yeah, that's definitely a good question to ask, actually. If you could find the answer to that or get close to finding the answer, that's also a plus. Alright, before we start our next study session, guys, I will be right back, so give me a quick second. Okay guys, I'm back. Sorry to keep you guys waiting. If you guys want to join the Discord server, please join the Discord server. It really like helps build up the math spellbook library, as well as like, you know, it allows us to like basically engage with each other more, and like, you know, if any of us got like awesome ideas like Bangbu has with what they're working on in their thesis, or what they try to aim for working on their thesis, like, yeah, like share your ideas, as well as like you know, like share your knowledge. That way all of us can enjoy and bask in like the intelligence that you're willing to share. Okay, let's see. I'm deciding between physics and math. Well, Famish, the thing of it is that if you like both subjects, my question to you is that do you like doing experiments more, or do you like doing theory? Because I remember this like question would pop up like whenever I watch like podcasts with scientists, especially Star Talk. Experiment sounds like fun. Because I think like I'm more of a hands-on kind of person. Don't go based on sounds. Read the syllabus. See if it's interesting. Yeah, if you're more of a hands-on type of person, yeah, like maybe like physics is the way to go, I think. But yeah, just like Bamboo said, read the syllabus, see what's in store for you. Because I mean, like, it's very interesting. I remember watching a podcast. I don't remember which YouTube channel it was, but I think it's like if you're more leaning towards theory, like if you want to go into theoretical physics, like I think like some physicists would suggest that you do math, because like the more math you know, the better that you will be at theoretical physics. Because I think like Bamboo, you could probably correct me if I'm wrong about this, but I heard that theoretical physics is mainly practiced in the math department. It's not really used in like the actual physics department in universities. Am I wrong about that, or is that like kind of like a fair assessment? Math major is AIDS. You will go insane. Physics is still manageable. That's fair. That's fair to say. Sorry about that, guys. I just had to turn on the lights in this room. Okay, I think it's time to get back into the grind. Okay, here we go. We still have to do this problem here. So I think we have one more to do, right? I gotta click on my tablet again. So we did that one. So now we gotta do B cross. Okay, so we gotta do it the reverse way. Okay. Not complaining. It's just pretty tedious. But then again, like, what's math without rigor, right? This is probably the rigor. I just want to make sure that I'm writing B right. Okay. And yeah, when it comes to like calculation math, I would get the techniques right, but I would get the arithmetic completely wrong. That's why like a calculator is my best friend. But sometimes I do mess up on one technique or two. No, it's practices in both. Math majors is manageable if you have a good program. In physics, it's more connected to experimental results and physical intuition, like quantum field theory, cosmology, and condensed matter physics. Never mind, mathematics had more than physics. In maths, it's more approached like on like, oh, okay, rigorous mathematical formulations of physical theories. Oh, okay. Yeah, I want to make sure that I was like if I was wrong about that, because I think I was like watching like interviews with like different physicists, and they would say, I think they said something like, you know, like people that want to get into theory should just like take mathematics, and then like if they want to do a PhD in like something involving physics, they basically do it through like mathematics instead of doing it through like just both double majoring in math and physics. But thank you for correcting me if on that. The foundations of mathematics, algebraic concepts, geometry, trigonometry, quantitative skills and reasoning, college algebra, the introduction of stats in Calc 1 and Calc 2. Like differential geometry and general relativity or category theory in quantum mechanics. Oh, okay. Wow, you guys are so knowledgeable. Okay, so this one is going to be Y and Z. So do that. This and that. This is I plus. Next one is going to be Z and X. and y, x and y, so... Uh-huh. Whew. Okay, bring out the calculator, because I am not multiplying 7. I'm not multiplying 17 to 4. It's in my head. I'm not going to bother doing that. Negative 61. Negative 36. Well, I didn't even have to type that in. It's 0. Of course it's going to be negative 36. Duh. That's positive 9. Okay. Oh. Okay. So when you switch it around, it basically just turns everything negative into positive. Interesting. That's intriguing. Very interesting epiphany we found there. Is that it? I think that's it, right? Oh, do not fall down. Yeah, so I think that's it. So we finished 2.5. Excellent. Excellent. Okay, 2.6. 2.6. For some stupid reason. Oh, okay. Let's see. Easy stuff. Not for you, but is this the syllabus for maths? First year. I memorized all the multiplication tables till 30 when I was 14. Oh wow. Till the day, I don't know why. Yeah, I think that's basically how it is with, like, regular school. It's like, they make you, like, do these calculations, and you're basically like, okay, I feel like I have to prepare for something, so I might as well memorize, like, all these different mathematical, like, arithmetic, questions, just in case they become useful. I think that's why people like read books on like how to do arithmetic, like, you know, do mental arithmetic and try to figure out the tricks. Not easy for me. Usually in a math major, you will, at the very least, cover the general theory of linear algebra, abstract algebra, theory of ordinary differential equations, topology, real analysis, and complex analysis. I'm getting through my immediate algebra classes. I'm struggling a little bit. That's normal. That's normal. I mean, like, is it college algebra or is it just? I mean, you said intermediate algebra, so I'm guessing it's just regular school algebra. Like, it's not like proof-based stuff, right? Famish? Or is it, or you do have to prove some stuff in your intermediate algebra class? Oh no, this is 2.7. I gotta do 2.6. For the function. F of x, y equals... Oh, this one's easy. So now we're getting into the partial derivatives. delta. Cool. Partial derivatives. Fun stuff. I love these. I think derivatives are my favorite because, like, they're much easier for me to remember. So derivative of f, boom, 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 2y, and 3. Right, so for f of y, we got, right, and then plus 2x, and yeah, that's easy. Going down a bit. Yeah, more advanced courses include PDE and differential geometry. Oh, I see. I'm just gonna check what I missed in chat, just in case if you guys typed up. Okay, so I read that. Okay, so I didn't miss that much. Okay, cool. When I said insane, I meant you will go insane later into the degree in both good and bad, because the questions you'll face. That's fair. I mean, like, you know, like, learning math, it could be like a very wondrous experience, or it could be just like going into a rabbit hole you can't dig yourself out of. So I get what you're saying, Bamboo. Let's see, just good old regular algebra. Okay. Like, I think with algebra, the thing that I remember from algebra is mainly like the manipulation techniques. But if it's something like deeper, I would have to like look it up again and then practice those techniques. But I think when you get in higher and higher math like calculus, you practice algebra like non-stop. Yeah, but don't feel bad that you're actually like struggling in the course, because, you know, that's normal. And like when you actually struggle through it, and you try to like study on your own, at your own pace, of course, like not before a test or anything, you begin to find like ways to actually like help your mind remember certain techniques, or your mind starts developing connections, and then you have to ask yourself, why is it that I can understand this connection? And then you ask yourself those deep questions, and it's like, oh, it reminds me of this scenario, or reminds me of this part of a pattern or something. Because you see the patterns in like math, and then you realize, oh, I'm developing a connection, and I didn't realize that connection was there. So yeah, don't feel bad if you're like struggling, because math is going to be hard. But once you get over the hurdle of one math subject, you begin to like feel confident in like going forward. Because like for me, I didn't know anything about proofs, and when I started writing my own proofs and I presented some of my proofs to Penn Center, he basically said that I think like 2 of the proofs that I showed him were pretty spot on, and I was pretty proud of myself of that. But at the same time, that doesn't mean I'm like an expert at proof writing or whatever. But it shows that I'm actually going in the right direction. But proof writing was such a thing that eluded me a long time. Let's see. I'm studying CSI and hopes to get a remote job. Then sometimes PhD level maths also comes in like an infinity category. Yeah, because you begin to learn stuff that goes beyond like just regular patterns and stuff that you're used to. Let's see. My one advice would be not to completely devote yourself to studying, like how, like, I know it's important, maybe love it, but keep it in mind, be healthy. Yeah, I agree. Because I think that's how many scientists and mathematicians kind of go into like this unhealthy relationship with themselves, because it's like they're so fixated on the problem, but the thing of it is that they're not taking care of themselves. And I kind of hope it changes. Like, people that are doing their PhDs or doing like academic work, I hope they can take better care of themselves, or have like an environment where they can feel like they can take care of themselves. Like, take care of their families, as well as like, look out for like people in their life. Like, have a social life at least. But of course, like, a lot of academics like to joke and basically say, huh, social life, what's that? I just research. Like, my work is basically taking a majority of my life. But at the same time, like, I just hope people like are able to develop like a life for themselves. I think that's what we all want. So this would be plus. I'm trying to best remember so I don't forget. So if we do B, I know the Z is unnecessary, but I just felt like writing it so I would remember. So the gradient for the gradient this matter would be the plus, yeah, because then, yeah, so at the position, okay, so now we got to do it, like this, where X and Y, well, actually, it should be, so 3 and -2, and then plus 2 times -3, so -4, therefore 2. Okay, what is at position? Okay, that, yeah, we got that. I think I'm missing something. Probably I'm missing something. I think I am missing something. Wait a minute, because I remember that a gradient is supposed to be its vector. Right? Yeah, I think the gradient is supposed to be a vector. So I think they're supposed to be like I hat, J hat, and then K hat here. So then J hat here. So that means it would be 6 I hat, and then -4 J hat. Oh, I was just looking at chat and like you guys are like just basically chatting a storm. Let's see. I'm starting to drink wine. I can't solve question. Yeah, it's good to relax and have like a good cup of wine. I like to try to dedicate at least 6 to 8 hours to study a day. I mean, good luck. Like, best of luck to you. I mean, like, I give you creds for being able to study that long. I can't study that long. It somehow makes me feel. It makes me think faster than slower. That's good. I have no social life. Oh, tears. I do extend research when I struggle and ask questions like why and how. That's good. It's fine to do, but like I don't want to discourage you, but let's see, usually in math it's much easier to choose a project than learn the required subjects it goes. Yeah, I agree with that too. Right now your level focus on your studying right now. Don't self-study and venture into advanced topic by yourself. Make your foundation the strongest. Yeah, that's true. My 2 cents, enjoy your life, whatever it is. Thanks, Phobo Stream. Thank you Thank you for that that advice. Yeah, that's what I'm doing right now. I write everything in a notebook and I read and try to do some research, as well as it takes longer, and then it puts, yeah, that usually happens with learning. Also increase the curiosity. Yeah, keep your curiosity strong, because I think when you grow older you start losing track of your curiosity. I believe this is the answer. Yeah, because I think like the gradient is supposed to be a, yeah, the gradient is supposed to be a vector, so basically you turn it into a vector. Nah, 1, 2, that's 4 bottles. More difficulty ahead. I have 5 notebooks filled. Nice. Not just math for all my classes. Oh, I see. Bring them on. My brain is so glad that you guys are like so active in chat. Okay. Okay, next I think is like 2, 8, so 2.8. Okay, find the divergence of the vector field given in the previous problem. Okay, so in the previous problem we got give the divergent field of the vector field. Okay. So I think it was the divergent field is like so they want us to give the divergent field of this one. So they want us to do it for the vector that we got? Vector field given in the previous one. Okay, so I'm guessing this is the vector field. Let's see, what is the gradient at the position? Vector field. Because this is the gradient, and a gradient is like a vector, so I'm guessing that is the vector field. Yeah, and I think it's basically asking for that. Right? So then, because I don't want to write this because it makes me feel like it's the Laplacian, but I don't think that's it. Because I know it's the divergence with a gradient that creates the Laplacian, but I don't think the question's asking for that. Maybe I should look up what they mean by vector field so I can so I don't be confused. Okay, yeah, I was right about the gradient. Luckily I caught that. I was like, wait, I'm thinking of the Nambla. I'm thinking of the Nambla symbol. Did Penn do the linear algebra course? I believe, yeah, like they already are doing the linear algebra course. I don't know how far they got into the course though. I have an answer for the next level, the next 2 levels. think he said he was going to do one today. I think they were doing one like a couple hours ago, I think, but I'm not sure. Now where was I? Oh yeah. Vector field. Let's see, the definition of a gradient of a scalar field, right? Yeah. You can find the spherical coordinates, divergence, parallel vector field. So I'm guessing the vector field is this. Oh, thank you for the follow. Oh, Axel1. If you're in chat, what's the best part of your day so far? And thank you for the follow. Appreciate it. Much appreciated. So there's algebra 1 and algebra 2. I believe so, yeah. There's usually like 2 algebras. I think I'm doing college algebra along with those 2. Oh, okay. Yeah, because like, yeah, algebra I think is split into 2, but technically it's kind of like 3-ish. Because like when you're in college, you usually take algebra 1, algebra 2, and then pre-calc. But I usually think of pre-calc as like algebra 3 with trigonometry in it. And quite honestly, I think pre-calc is just too condensed. Like it has too much in it. I mean, like I did take it for 1 semester and I passed it, but at the same time, I felt like my brain was about to explode because it felt like it was like too much. Because you have to learn like basic functions as well as like trigonometry and like the tricks with trig. Because I think there's some people that argue that pre-calc is not really necessary. Like I feel like if you separated the courses, like basically algebra 3 and then like you made algebra 3 and then trigonometry instead of just putting them all together, but I understand why they made it together. Because they just want people to be ready for calculus, and that's why they set up that course. Actually, I probably should just write what they wrote here, or what I wrote here, actually. And I think technically I don't have to write the units in there, the unit vectors. Let's see. But I did have a student come in today asking about spectral values decomposition. It was fun. I don't really understand it, but we got through the problems with the textbook, with the help of the textbook. I mean, that's cool. At least you managed to get through it. Let's see. I think I'll have to miss pen and Just linear algebra because I always work at those times. Oh, okay. I mean, that happens, yeah, because like we are all people and we have like busy schedules. But yeah, but then again, like, you know, like I think linear algebra, like the basic version without proofs, like you'll be able to like learn. I think you'll be able to like learn that like just by like looking through a book, I think. And if you have questions, like basically our communities are basically willing to like help you out with those. Let's see. Also, it looks like you're calculating the divergence for kind of phi instead of the divergence of phi. Maybe, yeah, because I'm starting to confuse myself actually. Because I keep thinking the vector field is something else, but it's probably this. Probably that is the vector field. Oops. Oh, where am I? Where's my mouse? There it is. So probably this is the vector field I have to calculate. Thank you for actually pointing that out, VamVoxFam. Because I was thinking, like, what do they mean by a vector field? Do they mean like the thing that I was calculating before? Or did they meant like the actual thing? Like, when you pointed that out, that actually makes more sense. So, oops. So we should probably erase this. Okay. All right. So then, plus. I think I'm overstepping something here. No. Go down. Now my brain is like, I think my brain is turning to mush. Because I'm like missing like basic stuff that I've learned before. And I'm like, why is my brain like suddenly turning into potatoes? Okay, so that's the gradient and the divergence. So the divergence is, it does have I in it, and it does have J in it. Wait a minute. Why am I suddenly getting confused? Because like the partial differential. Because then it would be like this, right? Because that's the same as the gradient, though. Isn't it? No, because it's supposed to be a scalar field. It's supposed to turn into a scalar, right? So I think I'm missing something here, because I know the divergence turns it into a scalar, right? Let's see. Since linear equations, inequalities, and next I have polynomial rational expressions, and oh yeah, fun stuff. Yeah, that's a long list. Yeah, that's a long list. Yeah, that's a long list, Famish. Yeah. Sequence and series is like, I don't think I ever covered that in my pre-calc class, actually. But I think like they started moving stuff up that I learned from my pre-calc to Algebra 2, actually. Because I remember like when I was looking at my nephew's like schoolwork, they were doing stuff that I was learning in pre-calc, and I was like, oh dang, they're pushing the subjects to like on like earlier. Because the divergence is like a dot product, right? So. Oh, wait. So... Oh yeah, because the dot product of... Oh, so it probably is this, I think. Because you have to have them like do the dot product so they can cross each other out, I think. But then again, like this could also be like... Yeah, because I forgot that the dot product basically annihilates the unit vectors. Turns out to be Y. So even if it's like X and Y, so it would be like this right here, then Y, J hat over here, and then if we enter the parameters of find the divergence of the vector field given in the previous problem. And I think if they want us to do it like the way they did it before, like with x equaling 3 and -2, that would leave us with... I mean, practically it's the same. But I think they need mostly this, I think. Because they didn't ask anything about the position, but... I'll just leave it at that. Yeah, that one I just got like majorly confused because I was like, wait, I'm doing stuff that I should remember, and I don't even like recall the basic way to think of it. It's like my mind basically was going to think of one direction, but I ended up thinking in a different direction. Okay. But I will check again to see if it's correct. Because I think my brain is like kind of like slightly fried. I think it was because of those cross products. Those cross products basically was pretty tedious. Like, what is the curl of the vector field given in the previous problem? Oh, wait a minute. I think I did the last problem wrong because I think I wrote the wrong question. I wrote the wrong question there. Because it says, let's see, the vector field, because I was reading two questions at once. So it wasn't the previous problem. We just carry this up here. It wasn't the previous problem. It was given by, that's why. The next problem is about the previous question. Z. Okay, that's why it was confusing. Okay. So dot product of C. That's the vector field that we were supposed to do. Now we know we're right for this. Don't you hate it when that happens? Like when you're trying to do a problem and then you read the questions wrong in the wrong way. It happens. It happens. We are all human after all. Oops. No. Wait. Is that his? Yeah, it's a Z. Because I know one of these has a Z, has an X, and I'm like, no, that shouldn't be there. Okay. Oh, and don't forget the K in front. Okay, so those will go away. And then we have 5y plus, well, should be negative 3, no, wait, what am I doing? No, that's supposed to be y, not x, so that means it's 0, so that's 0, then plus, then plus 10z. Okay, so that, yeah, so that is the divergence. Yeah, because we just have to put like the y, like we have to put y and z in there. Okay. Now on to question 2.9. Because like in total there's like 12 questions, but we didn't answer one of the questions in here. And I think like next week we'll probably like do those questions and then like look back and see what like if I have to check my work, see if I did anything wrong. Okay, what is the curl of, wow, that is so messy. Of the vector field given in the previous problem. The previous problem. Okay. Okay, so in the previous problem we had C is equal to 5xy I plus Should have waited. It's minus 3x j hat plus 5z squared. Okay. Now, the curl. Oh, this is a cross product, isn't it? It's a cross product. Fun. It's just the tediousness of it. Okay. But it's fine. It's fine. Because I know this is going to be a vector. Negative x and 5. Well, this will be fun. Okay, so y I think this is much easier to see though. Except I don't need the clock to go off. Minus x, and then C right here, then that's j, and then plus, now we gotta do x to negative 3 minus that's of k. Okay, so this will be 0, this will be 0, and this one will be 0, this one's 0, so they're all 0, except this one. This one will be, why did I put a plus? I meant to put an equals. So this one will be 3x minus 5x okay, yeah, that's how it looks. So I guess the vector field is going to be, yeah, it's going to be that practically. Okay, well, that's it for today's stream, guys. Thank you for joining me today, and if you're joining us for the first time, be sure to drop me a follow. I would really appreciate it, so that way we can keep growing our mathematical community and spread the vibes of math and physics and our inspiration for getting into the subjects. So if you got if you missed anything, or if you missed the first part of stream, or probably the middle of the stream, don't worry, I'll be uploading this VOD on YouTube, so you'll be able to catch up whatever you missed. So if you want to follow me, if you want to subscribe to my YouTube channel, you're more than happy to do so. I'm also going to be streaming tonight on my gaming Twitch stream, so if you want to follow my Uncle Talks Twitch channel, you're more than happy to do so. And if you want to join our Discord server, you're more than happy to join our Discord server, where we exchange ideas, or maybe just learn from each other about the subjects that we're learning. And I think that will be it for today. So thank you guys for joining me once again, and for all you guys that dropped a follow, I really appreciate you. Thank you very much. And always remember, guys, everyone is precious. You guys are just as precious as everyone else. And I will see you guys next week, or if you want to check out my gaming channel, I will probably see you there in a couple hours. So take care, guys. Bye-byes.